The idea of a conjugate is something mathematical that is a novelty that we tend to use to get us out of certain problems. And in this case, the idea of the complex conjugate is the idea that if we have a real number of the form a plus bi, for example, where a is a real part and b is the imaginary part, then the conjugate of this would be the same real part, but it would have a oppositely signed imaginary part. So, for example, these two would be the typical complex conjugates. So again, recognizing that the standard form is a plus bi, and recognizing that the only thing we change is the imaginary part, and only the sign. So for example, what's the conjugate of a? It's 3 minus 2i. All we did was change the sign of the imaginary part. Part b, what's the conjugate of this complex number? Well, we change this minus to a plus. This is the conjugate of this number. Part C, we only changed the sign of the imaginary number. So the negative 3 stays, but this plus 2i becomes a minus 2i. And so this is the conjugate of C. If it helps, let's rewrite part D as a full complex number. So 7 plus 0i, which means that the 7 is the same, but this would be a minus 0i. But come on, folks. Minus 0i, really? So in a weird twist of events, why is the conjugate the same as the original? Because there wasn't an imaginary part to change the signs. For this complex number, 2i, we could write it as 0 plus 2i, which means it would be 0 minus. We change this sign. We're changing this sign because it's in front of the imaginary number, the complex number. So this is a minus 2i. We don't write the 0, so we just do minus 2i. We probably overdid that problem. We could have just looked at this and said, hey, there's the imaginary part, switch the sign, minus 2i, done. So we could do the same thing here, right? If this is minus I, the opposite of that is plus I. But we don't write plus I, we just write it as I. So if we ask for the conjugates, that's what we're talking about. Okay, so let's take a second for problem 2. Let's look at part A. And I would prefer that you watch and not write this down. I would prefer you don't actually write what I'm about to show you down, because I want to show you a faster, better, cleaner, awesomer way. Okay, so just watch and enjoy. Learn from this. Appreciate the long work, and then recognize the beauty of the solution. So for those of you that do this the old-fashioned way, right? The FOIL, the first, outer, inner, last, you get 4 minus 6i. Remember, don't write this down. Plus 6i minus 9i squared. Now, we notice that this is a minus 6i, and this is a plus 6i, and they would cancel out. So we're left with a 4 minus 9i squared. But what is I squared by definition? We could replace the I squared with a negative 1. Now, some of you silly folks are doing 4 minus 9. That's not how order of operations. Order of operations says we take care of this multiplication first. This becomes a positive 9. And then I tack on this 4, and then 4 plus 9 is 13. And that's quite a bit of work. Now, let's recognize a few things. First, these are complex conjugates. Did you notice this? Like, if this is the original one, right? It has the same real part, that same 2, and it has the same imaginary unit, I, and they both have 3's, but one is a plus and one is a minus. So this makes it formally a complex conjugate. So, let's see part B. And again, don't write this down. I know you want to write this down, but I want you to kind of notice something here, okay? Just remember that this was 13. It was the final answer. Here's part B. Let's note that these are complex conjugates, right? The same real part, 5, 5. And then there's a plus 2i here, and there's a minus 2i here. So these are complex conjugates. Now I'm going to do this another way. the way I like to do these, right? But don't write this down still. Don't write this down because this is still the long way. I'm going to go and write this up here. Use my little box to distribute them. This first box is 5 times 5 is 25. 5 times 2i is positive 10i. Here we have a minus 10i. And then we have a minus 4i squared. And if I write this all out, we notice, interestingly enough, these cancel out. They're the same. Interesting. There seems to be a pattern going on here. And we get this whole idea of something minus something I squared. And you better be getting deja vu because this I squared is a negative 1. And again, don't write this down. It's too much work. And I didn't actually leave you space for you to write this down. Okay, I want you to enjoy the benefits. And then we go ahead and we don't do 25 minus 4 because order of operations is I need to multiply these two. So that's a positive 4. We get a positive 4 again. You could have gone back and replayed the last minute and applied it to this, and it's exactly the same thing. And I get a positive 29. Do you also note that in part A we got a 13, and in part B we got a 29? There were no negative answers, from what we can tell. And what's most important is there's no imaginary numbers. There's no I. So, and there isn't like a bunch of terms. It's just one number. So somehow, what I'm proposing to you is if we multiply complex conjugates, it's all going to work out the same. No matter if you multiply or if you FOIL or if you do the box, the middle terms are going to cancel out. You're going to bring in an I squared. It's going to make it into a positive, and you get a nice little number at the end. Fascinating. So, now I want to show you a trick that works all the time. And you're not going to find this in the Khan Academy or wherever else you go looking for extra videos that are longer than mine. This is a nice little trick that I found, and it works great. But you have to follow it with fidelity, meaning you have to do it exactly like I say to do it, okay, for it to work. Otherwise, if you can't handle the truth, you're going to need to go and do the box, do the multiplication, do the math, make mistakes. Okay, so check it. Here's what we do. This only works if we have complex conjugates. Okay, you ready? Here's what we do. You take this 2 and you square it. That's 4, right? Great. You take this 3 and you square it. And what's 4 plus 9? 13. It's that easy if you want to. Let's try with part B. So we would take the 5 and we'd square it. And we would add. We always add. And then we take we're taking just a 2. Please note, there are no i's in this trick. There are no minuses in between in this trick. Okay? Don't be putting the i's in here, you mess up the trick. If you're gonna do that, do it the old-fashioned long way with the multiplication. I'm just saying, take the real part, take the imaginary part, square them, add them at the end. So this is 25 plus 4, that's 29. Interesting. That was so much faster than doing all that extra stuff. Well, what about C, Mr. Rover? Well, you're not doing this. It works fine, right? These are conjugates, but it might be easier if you put the 1 there, because then people end up putting i's. And again, if you're going to make my little trick work, you don't put i's in there. Okay, so if we're going to use my trick, you're going to do 2 squared, then you're going to add it to 1 squared. That's 4 plus 1 is 5, the end. Okay. Part D, we take this negative 1 and we square it, which, by the way, if we use parentheses right, it comes to be a positive 1. We take the 3 and we square that, and that gives me 10. You can go back and check. You are very much free to try these problems out the long way and see how they come out to be the same. It might be worth your while to do it, okay? But then this only works. This only works for complex conjugates. It doesn't work if it's not a complex conjugate. So, for example, if E was 6 plus I, 6 plus I. Those are not complex conjugates. So my little trick does not work with these kinds of problems, and you have to go ahead and multiply the long way. And you're going to have to still for these videos, for the next video. But for this one right now, what I'm saying is if you have a conjugate, you don't have to do that. You take this number and you square it. That's 36. And then what's in front of the I? A 1. There's a 1 squared. That's a 1, and that's a 37. Okay? For your summary, explain in words, why the trick that we just showed you works and what it is. And perhaps even create another example, right? Why don't you create an example of two complex conjugates and then show how it works.